Example 5.3 book example. So in the இதுதான் problem statement. A cyclist comes to skidding stop in 10 meters. During this process, the force on the cycle due to the road is 200 newtons and it is directly opposed to the motion. So this force is a frictional force. Okay. How much work does the road do on the cycle? Similarly, how much work does the cycle do on the road? So இதுதான் உங்களுக்கு கொடுத்திருக்கிற question. Okay. ஸோ நம்மளுக்கு இங்கே என்ன இருக்குன்னா we have a cycle which is traveling and the cyclist applied the brake and it skids for 10 meters. Okay. ஸோ ரோலிங் ஆகல, ஸ்கிட் ஆகிருக்கு. ஸோ இட் ஸ்கிட் ஃபார் 10 meters. ஸோ இங்கேருந்து இது வரைக்கும் இட்ஸ் 10 meters. So this is the displacement. During displacement, the force and the force due to the road on the cycle is in the opposite direction and it is given by a value of 200 newtons. Okay. So displacement வந்து இந்த directionல இருக்கு, force இந்த direction இருக்கு. Okay. Therefore, the angle between the force and the displacement is given by, so ரெண்டு வெக்டர், இது வந்து force, sorry, இது displacement vector, another vector is frictional force. So frictional force in the direction. So frictional force வந்து FF, இதுதான் force vector and D என்றது displacement vector. This is equal to 200 newtons. So இதோட magnitude, அதாவது mod F. Similarly, displacement ஓட magnitude வந்து 10 meters. Okay, this is 10 meters. So they are asking to find the work done by the road on the cycle. Okay, so work done by the road can be written as mod F vector mod D vector cos theta, and the theta here is 90 degree, sorry, 180 degree. So 180 degree, or in radians we have pi radian. Okay. So this is the angle between the force and the displacement vector. Okay. So therefore cos 180 is, it's minus 1. So the work done by the force is 200 into 10 meters into minus 1. Therefore it's minus 2000. Since the work done is nothing but energy, so its units, it's joule. Okay. So this is the work done by the road on the cycle. Okay. So the next question is, what is the work done by the cycle on the road? Okay. So to answer that, so it is a tricky question also, you should be very careful. So next part we are finding work done by the cycle on the road. Okay. So the force due to the cycle on the road is equal and opposites. Therefore, it should be um, minus 200 newtons. Okay. So, and what's the displacement? So what's the displacement? Here the displacement is 0. Okay. So mod Fc, this is the force due to the cycle on the road, is equal and opposite due to, this is due to Newton's third law. However, there is no displacement because the cycle doesn't displace the road. Okay. So since there is no displacement, we can calculate the work done by the cycle on the road is mod Fc vector mod D vector cos theta. Okay. So here we have minus 200 into 0 into cos theta. Okay. So it is obviously 0. Therefore, the work done by the cycle on the road is 0. Okay. So force can be equal and opposite, but work done வந்து எப்பயுமே equal and opposite இருக்கணும்னு அவசியம் கிடையாது. ஓகே, ஸோ ஒர்க் டன் ரெண்டு கண்டிஷனில் வந்து it becomes zero. ஓகே, even there is a presence of force. ஒன்று என்னதுன்னா, if there is no displacement, then W is work done is zero. Okay, also if the angle between force and the displacement is 90 degree, that is, if theta equal to 90 degree, work done is zero. இந்த ரெண்டு கண்டிஷன்லையுமே ஒர்க் டன் வந்து ஜீரோ. ஓகே, ஸோ இது உங்களை ஏமாத்துறதுக்காக they have asked this second part of the question. So next we move on to the next example problem 5.4. This is also a book problem. So the question is this follows. Okay, so in a ballistic demonstration, a police officer fires a bullet of mass 50 grams with the speed 200 meters per second on a soft plywood of thickness 2 centimeter. The bullet emerges with only 10% of its initial kinetic energy. What is the emergent speed of the bullet? Okay, ஸோ யூஸ்வலாக பெலஸ்டிக்ன்றது என்னதுன்னா இட்ஸ் அ கண்ட்ரோல்டு டெஸ்ட். ஓகே, ஒரு லேபார்ட்ரியில் தே வில் பர்ஃபார்ம் சம் டெஸ்ட், தே வில் ஃபயர் புல்லட் வித் நோன் மாஸ் ஆன் certain materials, so as to collect some data. ஸோ இதுதான் நம்மளுக்கு டேட்டா. We also have a table for this. So for bullet, the speed is approximately 200 meters per second. Okay, so they are asking us to find what is the emergent speed of the bullet after it passes through the soft plywood. Okay, so நம்மளுக்கு we have to find the kinetic energy, initial kinetic energy. So the initial kinetic energy ki is nothing but of mv square, which is equal to of uh, 50 grams is 0.05 kilogram, and the velocity is in SI unit, therefore no problem. So it's 200 meters per second. So this reduced to a value of 1000 joules. Okay, so this is the initial kinetic energy of the bullet. So with this initial kinetic energy, the bullet passes through the soft plywood and emerges with only 10% of the kinetic energy, original kinetic energy. Okay, therefore the final kinetic energy, final kinetic energy Kf is zero point 0.1 times 10% is 0.1. Okay, zero point 0.1 times of the initial kinetic energy. Therefore, Kf equal to zero point 0.1 into 1000 joules. Okay, which is 100 joules. So this is the final kinetic energy, but they asked to find the emergent speed of the bullet. Okay, so we know that the final kinetic energy is nothing but of m vf square. Okay, so the mass never changes for the bullet if we assume so. Then we can write which is of into 0.05 into uh, VF. This is the thing we have to find. Okay, but this side we have calculated which is 100. Okay, 100 joules. Therefore, rewriting this equation, we can have VF square equal to 2 into this 2 goes this side, 2 into 100 divided by 0.05. Okay, or VF equal to root of 2 into 100 divided by 0.05. This value is approximately 200 divided by zero point 0.5 is root of 4000. Okay, so this is 63.2 meters per second. So this is the final velocity. So initially it was traveling at a velocity of 200 meters per second, but after passing through the soft plywood, it emerges with this velocity. Okay, so it allows us approximately how much. Let's calculate. So the loss of velocity is equal to, so initially it is traveling at 200 minus 63.2 divided by the original, okay, into 100 gives the percentage. So it is approximately 136.8 divided by 200 into 100. Okay. So this value is 0.684 into 100. We have a percentage here. Okay. So it is approximately 68.4, or we can write it as 68 percentage. Okay, so this is the percentage change in velocity. Okay, so this is, you no need to calculate this, but this is just to make how much the velocity changes in percentage. Okay, so it is initially 65% more than the final velocity. So we can move on to the next problem, which is exercise 5.5, example problem 5.5. So this is the problem statement. A woman pushes a trunk on a railway platform which has a rough surface. Okay, so friction involves. She applies a force of 100 Newton over a distance of 10 meters. Therefore, thereafter, she gets progressively tired and her applied force reduces linearly with distance to 15 Newton. Okay. So 100 இருந்து 15 Newton குறைஞ்சிருச்சு. Okay. So the total distance through which the trunk has been moved is 20 meters. Initially, she moved from 0 to 10 meters at a range of at a force of 100 Newton, and after that she reduces linearly to 50 Newtons and reaches 20 meters. Okay, plot the force applied by the woman and the frictional force, which is 50 newtons versus displacement. Okay, they are asking to plot a force versus displacement plot. Okay, calculate the work done by the two forces over 20 meters. Okay, for that we have to make a plot. So let's draw a plot. Since we have a frictional force, we need a negative axis too. So let's take the forces along the vertical axis and the displacement along the horizontal axis. Okay, so this is the force axis and the horizontal axis. Okay, so the applied force is so let me use the picture used in your book. So it's 0, and you have 50 newtons, and here we can put 100 newtons, the fine, the initial force. Also there is a minus 50 newton here. Okay, this is the frictional force. So the woman initially travel up to 10 meters with a constant force of 100 newtons. Okay, so till 10 meters she traveled with a constant force of 100 newtons. After that, she traveled another 10 meters, to reach 20 meters from this point. At that is from 10 meter onwards, she got tired, and her applied force starts to decrease linearly. Okay, therefore it should be a linear slope. Okay, so it should decrease and reach 50 newtons when she reached 20 meters. So the force reached 50 newtons. So this is the plot. So this is up to 10 meters, and from 10 meters the the applied force reduces linearly and reaches 15 meters. Okay. Sorry, 50 newtons. So this height is 50 newtons. So this should be 50. So this height is 50 and this height should be 100. Okay. And this is 10. This distance is 10 and this distance is also 10. Okay. So we have a rectangle, so we can name it. So let it be, this is A, B, C, D, and we can name this as, so let it be this point BD. Okay. And C, E, I. This point is I. Okay. I am using the name given as it is in your book. Okay. So they also asked us to plot the frictional force. Okay. The frictional force remains constant throughout the entire displacement. Okay. Therefore, it should be minus 50 newtons and throughout this entire displacement. So let this point be G and this point be H. So this is G and H. So the work done by the woman is this entire area. Let me mark with the red color or we can use green. So this is the work done by the woman. So this area. And the work done by the frictional force is the underlying rectangle. So let me mark with the red color. So this is the work done by the frictional force. So the total work done is uh, so what's the question? They asked to calculate the work done by the two forces. Okay, one which is the force applied by the woman, and another thing is the force due to the friction. Okay, so work done by the woman as first கண்டுபிடிச்சிடலாம். Okay, so work done by the woman. So அதை வந்து WF எழுதலாம். Okay, WF. So WF equal to, it's nothing but the area under the curve. So uh, between, so this entire area which contains an square rectangle and this rectangle and a trapezoid. Okay. So this work done by the woman is the area of rectangle ABCD. This is for x between 0 and x equal to 10. Okay, and she has after that her course linearly declined and she travels some another 10 meters. Okay, so it is the area of the trapezoid. So that trapezoid is CEID, which is from 10 meters equal to 10 meters to x equal to 20 meters. So therefore, the area of the rectangle is, it is base into height. Okay, the base is 10 meters and the height is 100 joules, sorry, 100 Newton. Therefore, 100 into 10. Okay, so 100 Newton into 10 meters. Okay, plus the area of the trapezoid. Okay, so area of the trapezoidal is given by half into length addition of two sides, which is 100 Newton plus 50 Newton into base, which is 10 meters. Okay, so one side is 100 and another side is 50. So we have to add those sides and multiply by half, and we have to multiply by the base, again the base. Therefore, we have this quantity is 1000 joules plus 750 joules. Therefore, the work done by the woman is against the frictional force is 1750 joules. Okay. So, in the same period, the floor also done and work against that woman's work. Okay. So, we have to calculate that one also. So, work done by the frictional force. So, frictional force. Let me name it as W small f. Okay, so W small f is nothing but area of the rectangle AGHI. Okay, so this rectangle AGHI, I marked with red shade, which is equal to base into height, which is minus 50 Newton into the base is 20 meters. Therefore, it's minus 1000 joules. Okay, so the area on the negative side of the force axis. Okay, so this is the work done by the frictional force. Next, we move on to the example 5.6. So this is the problem statement. A block of mass m equal to 1 kg of mass 1 kg moving on a horizontal surface with the speed initial speed, this is initial speed of 2 meters per second, enters a rough patch ranging from x equal to zero point 0.1 to 2.0 meters. Okay, so the retarding force on the block in this range is inversely proportional to x over the range. So they give the form of the force. Okay, so and this force is 0 for range from zero point 0.1 meter to point 2.01 meter. Okay, so where k, they also provided the proportionality constant k. Okay, so this is the problem. So initially from x equal to 0 to x equal to zero point 0.1. Okay, so till zero point 0.1, let it be this point be zero point 0.1 meters. Okay, to so with this distance f of r is 0. Okay, there is no retardation force. The retardation force comes to play at zero point 0.1 meters. Okay, from this point to around this distance. This distance is x equal to, this is 2.01 meters. Okay, so this distance there is a retardation force Fr equal to, let me write here, Fr equal to, so this is the rough patch, rough region. So in this region f of r equal to 0, and after this region also f of r equal to 0, but in this region f of r is given by minus k by x, inversely proportional to the displacement. Okay, so this is the displacement. So the displacement is between this point to this point. So the block is gliding from here. Okay, so it is initially gliding with the initial velocity of 2 meters per second. So this enters the rough patch, and they are asking to find the final velocity of the block after it crosses the rough patch. Here, what is the final velocity? By work energy theorem, we know that the change in kinetic energy is equal to the work done. So delta K equal to the work done. But delta K, change in kinetic energy, is final kinetic energy minus initial kinetic energy. And here the work done is, since the force is a variable force, okay, so it directly inversely proportional to the distance, so it's a variable force. So we have to use the integral form from x initial to x final, f of r and dx. This is by work energy theorem. By work energy, theorem, we have this relation, and we have separate formula for both of this. Okay, so here the initial position is xi equal to zero point 0.1 meters, I think 0.01. So this one we have to read it carefully. 0.1, and x final is 2.01 meters. Okay, and we also have for f of x, and we have also the value for k equal to zero point 0.5, equal to zero point 0.5 joules. So it's possible to integrate. So the work done equal to integral 0.1 to 2.01 minus k by x dx. Okay, so we can take this k outside. So minus k integral the 0.1 to 2.01 dx by x. Okay, so in integration we have a formula for this. So this can be written as, so this is an integral formula, integral dx by x equal to natural logarithm ln x plus c. Okay, if it is a definite integral, then we have to integrate within the limits. So if we have xi to xf, then we have to put the limits. So this is formula. Okay, so we are going to use the same formula. Instead of xi and xf, we have zero point 0.1 and 2.0. So we also have value for k. So k is 0.5, and the integral, if we evaluate, it's ln, we have to call this as ln. Okay, natural logarithm ln, which is nothing but log base e ln x of value between 0.1 and 2.0. So this zero point 0.1, oh, sorry, zero point 0.5 into log, sorry, ln zero point 0.1, sorry, upper limit. So this is equal to zero point 0.5 into upper limit is ln of 2.01 minus lower limit 0.1. Okay, so we have to calculate this natural logarithm. In the exam, they will provide the table, ln table for you, so you can calculate. So I have referred the value from the book. So it is minus, we have a minus here also. Okay, so this is minus k. Okay, so we end up with minus 1.5. So this value, this whole value is minus 1.5. This is the work done by the frictional force, 1.5 joules. Okay, so this work done is equal to the change in kinetic energy. Change in kinetic energy is kf minus ki equal to this w, which is minus 1.5. Okay, so we have to find k initial in order to find kf, or we can write kf equal to ki minus 1.5. So ki is of mvi square. Okay, so we have the mass of the block and we also have the initial velocity. Therefore it is half into the mass of the block is given as 1 kg. Okay, so it's in 1 kg itself, and the speed is 2 meters. So it's 1 into 2 meters, so it should be 4. Okay, so 2 into 2, and we also have minus 1.5 here. Okay, so minus 1.5, so whole thing into, well, minus 1.5. Therefore here this 2 and 2 goes, so we end up with the 2 minus 1.5. So this is the final kinetic energy. Therefore the final kinetic energy is zero point 0.5 joules. Okay, so from this we can find the velocity, final velocity. Okay, they are asking to find the final velocity when it exits the rough patch. Okay, so what is the final kinetic energy and speed of the block as it crosses that rough patch? So we have calculated the kinetic energy when it exits the rough patch. From this we can also calculate the final speed. Okay, so it is given by this kf is nothing but of m vf square. Okay, so m we know, which is already used, it's 1 kg, therefore half into 1 into vf square. This is our kf, which is zero point 0.5 value. Okay, so we have kf equal to 0.5. I use this value. So from this we can find the vf square equal to, we can take this 2 this side, therefore it is 2 into zero point 0.5, which is 1. Vf square equal to 1, or Vf equal to root of 1, which is 1. So 1 meters per second. So the exiting velocity or the exiting speed is 1 meters per second. So the block enters at a speed of, initial speed is 2 meters per second, and it encounters a rough patch, and after that its speed slows down, and it reaches a final value of 1 meters per second when it exits that rough patch. Okay, so this value is 1 meters per second. So example 5.7, 5.8, 5.9. Okay, so these three examples I have already worked out in video number 5, 6 and 7. Okay, along with the theory class I have worked out this example. So now I will stop this class. We can continue with the exercise problem in the next class. Thank you.